Good morning. We're going to talk about the remainder theorem and the factor theorem. Both use the ideas of synthetic division. For the remainder theorem, we call it synthetic substitution because we're just substituting the value we're given to input into this function. So before, when we were working with these functions and we wanted to input a value for x, we would just go ahead and input it and then do the math. So what I want to do is show you first what that answer is going to be. Okay, so before we went ahead and let me change the color on this real fast. Before we just input values. We said, okay, well, if we're inputting 5, I have negative 3 times 5 squared plus 5 times 5, because I'm inputting that 5, and then minus 1. So then I would do this math, and 5 squared is 25, times negative 3 is negative 75. Okay. Now, we're going to add to it 5 times 5, which is 25, and then we're going to subtract 1. Well, negative 75 and positive 25 is negative 50 minus 1. So our value for f of 5, when we input and do the math, is negative 51. Okay, so now we know what our answer should be. Let's go back and go ahead and use the synthetic substitution and do the math this way. So you're given f of 5. So you put that 5 in the box. And what you come out with here, this last thing, this remainder right here, we call this our remainder. We've talked about that before. But we don't have to do anything special with it. It just gives us a value of what happens if we input the 5 instead of going back and doing something else like we did with division. This is synthetic substitution. We're just substituting that value for x. So I've set this up with the coefficients, negative 3, 5, and negative 1. And my first step, obviously, is to drop this down. Now I have negative 3. 5 times negative 3 is negative 15. Negative 15 plus positive 5 is negative 10. 5 times negative 10 is negative 50. Negative 1 and negative 50 are negative 51. Look at that. We have the same answer as we got up here. All right. So if I go backward, let's see if I can get rid of most of this. All right. So what I'll do is I'll get rid of this guy. We'll do it with the next one. And get rid of that. And I'll erase here. Hey, I'm erasing. I'm erasing. There it is. All right. Sort of painted over it. Let's go back here. Use our pen if it's going to let me. My machine is being mean to me today. All right, here we go. I'm going to try and input 5 again, but I'm going to use this second function here. And the reason I'm using this second function here is we need a space holder here. There's no x value. So let's go ahead and use 5 again. And I'll put in our coefficients, negative 1, 3. There's no x here. There's no x value, so I'm going to put in a 0 to hold its place, and then negative 5. And I tried to space it out so that we could get the remainder sitting here. So first things first, we drop this straight down. And that's negative 1. 5 times negative 1 is negative 5. Positive 3 and negative 5 are negative 2. 5 times negative 2 is negative 10. Add them together, you still get negative 10. 0 plus negative 10 is always going to be negative 10. 5 times negative 10 is negative 50. And negative 5 and negative 50 are negative 55. And that's how you do that. Okay? We're going to do the same thing with the factor theorem. And all it is using synthetic division with a root, and there's just a little bit of a difference. I'm going to say here, use root. That's the key. And I'm going to explain to you what the root is. The root is that value that tells us where this function, because this is a cubic function, it looks something like this. It goes up, turns, and goes up again. It may twist a little, but it turns, right, and goes upward. It may not go straight like that. It may be slanted a little bit, but that's basically what it is. We want to know where this function crosses the x-axis. And it could have up to 3 roots because it has a degree of 3. All right, so what I want to do is find out, what do I put in the box here? Well, here's what I put in the box. I want to say x plus 2 equals 0. Right? So what value plus 2 equals 0? Well, we do the math. We subtract 2 from both sides. Obviously, negative 2 plus positive 2 equals 0. So I'm going to put this negative 2 in the box. So remember, like the time we did division, if we wanted to divide by this binomial, we would use the root. Instead of the positive 2, we would put the negative 2 in the box. That is why we do this, right? Because if this were an equation, we would be set this whole trinomial here to 0 and make it all work. All right, so let's take care of this one. The next thing we have to do is put in our coefficients, and I'm getting bored with that color, so let's go ahead and use this one. Coefficient. Our first coefficient is 1. The next is 0 because there's no squared term here. So I'm going to put in my placeholder of 0. The next one is 1. And the last one is 10. And I'm sorry I didn't space it out right, but I think you'll be able to forgive me for this. All right. First things first, drop it down. Right? Now, negative 2 times 1 is negative 2. Add these two things together. I don't know why I'm working on a slant like this. I got negative 2. Awesome. Negative 2 times negative 2 is positive 4. So 1 plus positive 4 gives me 5. Looks like this is a factor. Negative 2 times 5 is negative 10. Positive 10 and negative 10 give me 0. All right? So, as before, when you were looking at substitution, we could think of this as, hey, when I input negative 2 into this function, I'm going to get a 0 out. Right? But now I'm looking at it as if, okay, well, this x plus 2 is one of the factors, one of those sets of parentheses, because when I have a cubic function like this, I'm going to look for 3 sets of parentheses, right? And we already know that one of them is x plus 2. We've been given this, and we found out that we have a 0 remainder. So remember, in division, what we looked at when we had this set of coefficients on the bottom, they were our coefficients of what happens when we factor out x plus 2. So I'm going to drop the degree of the polynomial by 1. And I'm going to put in, and let me change color on this so you can see it a little bit better. So I'm going to put in an x squared. I dropped the degree by 1. Now it's x squared, negative 2x, and plus 5. Okay, so that's my new polynomial, right? So this polynomial here times this is going to give me this original function. So now all I have to do is factor, let's factor x squared minus 2x plus 5. And then there are all those questions that you have to ask yourself, what do I put in these parentheses? I need to find two sets of binomials, and when I FOIL them, I come up with this. And first things first, I just want to look at this operation symbol here, and we see it's addition, so the signs inside the operation symbols have to be the same. Well, if they have to be the same, then I look at this right here, second, and I know that they have to be subtraction. And I think I've gone over this, I don't know, maybe 60, 70, 150 times this year, trying to make sure you understand the process of reading the operation symbols to know what's in here. Then you can start playing with the ideas herein. And while I'm looking at this, I'm seeing that I can't factor this, so I must have made a mistake up here. I'm trying to see if there is a sign that I messed up. Drop that down, that's negative 2. And 2 is positive 4. No, it looks right. I can't have factors of 5 that when you add them together you get negative 2. So I guess, for now, since this isn't factorable, we're just going to leave this one as an answer. There is a non-real root in here that's going to get us here, because even if I put in a 5 and a 1, that is positive 5, but if you put in your x and your x, they don't work, do they? And I'm looking up here, yeah, seems to be about right, but okay. So this doesn't work, because this negative 2 wouldn't exist. You'd actually have negative 6 if you did it this way. So there is a non-real root in here somewhere. So most likely your function will look like this when you graph it on your calculator. Sorry I got into a confusing bit, but if you can factor it, that's what you're going to do next. Let's try the next one, because it's probably going to be a lot better. So let me start getting this stuff out of the way. That won't work. I'm not having a good day today at all. Making my life tough. And last but certainly not least, this guy in here. Get rid of that. So here we go. We're looking at minus 6, or we're going to have to change what's inside here, aren't we? Oopsie. Forgot one. So we'll get rid of that. Now, if I have minus 6, that means x, can't see it, x minus 6 equals 0. So what minus 6 equals 0? That's positive 6. So you put the positive value, the opposite value in the box. This is my reminder. Then we'll list the coefficients. First coefficient is 3, then you have negative 13, then you have positive 24. That's positive 24. Hey, today. 24. And, oh, that's why, because I didn't put in the negative 34. Thanks for correcting me. Negative 34 and positive 24. Sorry about that. Woof. And now we're going to do some math. Okay. And there we go. Drop it down. We have 6. 6 times 6 is, that's a 3, dummy. Drop it down, that's a 3. I'm looking up here at the 6. Now we have 18. Ooh, that's great. 6 times 3 is 18. Negative 13 and 18 is 5. 6 times 5 is 30. All right, negative 34 and positive 30 are negative 4. So 6 times negative 4 is negative 24. I left the 0 there for a reason. We know that x minus 6 is one of our factors. Now I'm going to drop the degree down. So this is going to be 3x squared. It's positive here, so I'm going to say positive 5x and minus 4. So that's my new trinomial. So I'm going to look for values that are going to make this factorable. And I'm looking at it now, and I'm assuming that we could factor this. I know I have x and x. One of them is going to be a 3, and one of them is going to be 1, because there's only one way to get the number 3 through multiplication. It only has factors of 3 and 1. I know for a fact, because I'm looking at this operation symbol, that I am looking at a sum and a difference. But what I'm going to try and do is I'm going to try and find values or factors of 4 that will give me a positive number here, or a positive 5 when I find their difference. So, 3 and 2, that was 6. And then 2, 6 minus 2 is not 5. This one isn't factorable easy either. This is mean. Why are they being so mean? I guess because let's just try one. You know, let's try. There are only 2 sets of factors, right? So we'll use 4 and 1. We'll see if that works. 3x. Oh, 1 has to be subtraction. So negative 3x and positive 4x does not give me 5x. So let's use 2 and 2. Negative 6 minus negative 6 and positive 2 are negative 4. So they don't even come to 5. So this also is not factorable with real roots. So no other real roots. This is the only real root that you're going to get out of it, just like the last one. So if you can't factor it easily, once you get here, now you know you have some imaginary roots. And I don't want to start talking about imaginary roots yet. You're going to get to that when you get to pre-calc. Start talking about the imaginary coordinate plane, or we start talking about polar coordinates. So really, it only has one real root, so you'll just see cubic function that looks like that. Has one turn. It does. There are other cubic functions that will, start up, dip down through the x-axis and cross a couple of times. All right, but this one doesn't. And that's really how you do it. I guess what the textbook is wanting us to do is just that, and not factor the rest of it. I guess that's the way it is. So I apologize for making you go through this step, but it is necessary. You will run into cases where you'll be able to factor the rest of it. And I'm just going to see if I can show you one that works that way. Let's just go here and get rid of that. Let's try one last one, and I'm going to do it real fast to see if we can make this work. I want to see if we can factor one. X cubed plus x squared minus 10x plus 8. And we're going to look to see if, let's see if x minus 2 is a factor. And so if it's x minus 2, then we show the opposite of minus 2, and we'll put positive 2 inside the box. And then we'll have 1, 1, negative 10, and positive 8. And pardon me for my not straight line, but at least I have it lined up the way it's supposed to be. All right, so we'll start doing the math. We'll drop this 1 down. Multiply 2 times 1 is 2. Add them together, you get 3. 2 times 3 is 6. Negative 10 and positive 6 is negative 4. 2 times negative 4 is negative 8. And we have 0 as a remainder. Right? Finally, we have something that we can factor. So you drop this down 1 degree. So you have x squared plus 3x minus 4. Well, we can factor this bad boy. X squared plus 3x minus 4. We're going to factor it into two binomials, those two things. Now we know that this works, so we're going to end up doing this. We know that x minus 2 is one of those roots. Now, x squared plus 3x minus 4, we know that we have a difference here, right? We have a sum and we have a difference. We know that x times x is x squared. Remember, because we looked at this, we have a sum and a difference. We need factors of 4 that when we find the difference between them, when we subtract, we end up with 3. Now the only way we can do that is 4 and 1. 2 and 2 don't work, right? Because when you subtract 2 from 2, you get 0. So this is the only thing that's going to work. So I want my 4 to be positive. I want my 4 next to the addition sign, and that would leave my 1 right here. And this is fully factored. So, just to recap, we use synthetic substitution to find out what the value is when we input a value for x in our function, and then we use synthetic division to find factors of our cubic functions. And this particular function would come up, dip down, and come back up, right? It would cross at -4. Say negative. Oh God, that was a horrible. So that would be -4 would be one of the roots, and then we have the y-axis cutting through here. This would be 1, and this 0 would be 2. So they would be closer together, but you see what I mean. Poor drawing. Go back to art school. Anyway, I hope you guys understand that. It took a long time, but we got through all of it, and I was able to factor 1 completely.